Assalamualaikum and good day to Dr. Abdullah. We're from Group 1 and today we're going to present to you Shirul. But first of all, let me introduce you the group members, which is first, we have Ayman Shafiq bin Muhammad Nasir. Second, we have Hairi Zikri bin Zulkifli. Third, we have Jonathan Tanjit Leong. Fourth, we have Nur Kamalin Mastura bin Muhammad Zulkifli. And me, myself, Dayang Alia Farzana binti Awang Muhammad. So, without wasting your time, let us move to the next part. Hi, here we met again. So, for the introduction, did you know shear wall is the structure of members in a reinforced concrete frame structure to resist lateral forces such as wind forces? Shear walls are generally used in high-rise buildings subject to lateral wind and seismic forces. In reinforced concrete frame structure have effect of wind forces increase in significance as the structure increase in height. Codes of practice impose limits on horizontal movement or sway. So I'm gonna explain to you three main points of objective in shear wall. First, we have studied about failure of shear wall in building. Second, to identify the types and classification of shear wall, advantages and disadvantages of shear wall in building. Last but not least, we have to identify and propose a method suitable for maintenance and prevention of failure in shear walls in a building.
Hi, Assalamualaikum. My name is Nur Kamal Mastura binti Muhammad Zulkifli. My metric number is BFC21003. In this slide, I will explain about background study, where it's about the shower is structural panel that can resist lateral forces acting on it. Lateral forces are those that are parallel to a plane of the wall and are typically wind and seismic loops. Shower are particularly important in large or high-risk buildings or buildings in areas of high wind and seismic activity. In residential buildings, showers are extended from a box, which provide all of the lateral support for the building. Reduce lateral sway of the building, provide large strength and stiffness to the building in the direction of their orientation. Students are recommended to know about advantage, application, and design of them. In structural engineering, a shear wall is a structural system composed of braced panels, also known as shear panels, to counter the effect of lateral and load acting on a structure. Wind and seismic loads are the most common loads that shear walls are designed to carry. Vibrations which are caused under the Earth's surface generate waves which disturb the Earth's surface. In terms of earthquake, it was said that earthquakes would not kill humans but structures which are not constructed considering the earthquake force do. Shear walls are built to resist the lateral forces produced during earthquake or wind. Shear walls behavior depends upon the material used, wall thickness, wall length, wall positioning in building frame also. Explain about literature review. For the first one is based on P.P. Chanduka and Dr. P.S. Pajgate. They said shear walls are one of the best ways to make multi-story reinforced concrete buildings earthquake resistant. During earthquakes, the building is still affected for several reasons. The distribution of weight, stiffness, and strength in both horizontal and vertical planes of the building determines how the structure behaves during an earthquake. The second one is KVJD Balaji and Murugesh D. Shah. And it says about structures built on flat ground and inclined terrain with 30 inclination are both examined. Different structures with different base size in two directions are explored in plane symmetry and also asymmetry. Because nonlinear static analysis is an iterative technique, it is difficult to solve using human calculation, which is why software is essential. The third one is Muhammad Abdul Sattar. The research focuses on RC height-raised building with shear 1, outrigger and bed truss that are 15, 20 and 25 floor tops. The building's layout is a bay frame with a span of 40 meter multiplied by 40 meter with column space 5 meter apart from center to center. ETAP software is used to do analysis for both wind and seismic load against numerous parameters. And the last one is Hildago PA and Ashraf M. The influence of shear wall position on axial and shear forces, as well as bending and twisting moment of beam and columns, was investigated. It was reported that moving the shear wall further from the center of gravity increased the forces of the majority of the members. The shear wall should be situated such that the building's center of gravity and centroids coincide with each other to minimize forces in the member.
Hello, my name is Jonathan. My method number is CF210052. So I will present of the solution part for the application of the shear wall in building. So the shear wall are designed to resist the gravity or the vertical load and the earthquake or wind lateral loads. So this type of the wall are structurally combined with the roof or the floor. Other lateral walls run at the right angle to provide the three-dimensional stability to structure. This wall have to resist upfield force due to the air drag, and this wall resists the shear force and try to push the wall up and the lateral force of air that push the walls in and out of the structures. Characteristic of the shear wall. So first we have the load and the design load. So the service load is the actual load that the structure is designed to carry. So aesthetically, it must not exceed of 95% of probability. So there are four types of load: dead load, imposed load, wind load, and the earthquake load. So we jump to the function of the shear wall. So the function of shear wall is to resist the seismic force, wind force coming on the structure of the building and to provide stability of the building. So next is to reduce the impact of the external force on the building. And the third is to provide great strength and inertia for the construction of the structure of the building. And the efficiency of shear wall probably depend upon its rigidity, and a solid shear wall is more efficient than the shear wall with opening. But sometimes it's not possible to construct a shear wall without opening, such as doors and window and so on.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shafiq and I will present about type of shear wall, advantages and disadvantages of shear wall. What type of shear wall that we use in concrete in building is first, reinforced concrete wall, steel shear wall, third, concrete block wall, fourth, plywood shear wall, and lastly, mid-ply shear wall. Okay, I will continue about advantages and disadvantages of shear wall. For advantages of shear wall is the wall has good resistance to structural and non-structural element in earthquake-like condition, so as to reduce damage to the element of the structure. Second, the design of shear wall in the building works efficiently in terms of reducing the cost of construction and earthquake damage. This wall can be made in different shapes as required and it can provide proper reinforcement in the design of the shape. Last for advantages is this wall supports the structure of the building as a thinner wall. Disadvantages of shear wall is supervision is required for adequate compaction during concreting of shear wall in formwork. If care is not taken, the void remains in the shear wall. Therefore, the strength of shear wall decreases. This type of wall does not have any opening. Shattering this type of wall requires skill labor. And last, it is very difficult to place reinforcement in the shear wall. It is also difficult to place reinforcement, especially in C type of shear wall. Thank you from me, and we'll continue with next presenter. Thank you.
As the conclusion, shear walls are one of the most effective building components. Shear walls cross-section will give more building stiffness and minimizing damage. Strong penetration, low viscosity, edging water resistant, acid alkaline resistant are some of the key characteristics of the exposite injection concrete crack repair. For the recommendation, one of the most effective numerical methods utilized for analyzing reinforced concrete members is the numerical models that have been created so far can divide it into two categories. One is microscopic models and one of macroscopic models. And to simplify the computation in two nonlinear global structure analysis, particularly for large and complex structure, a macroscopic models that can be simulated, the key aspect of nonlinear behavior is desirable for engineering practice.